Hello, and in this video we will be looking at the mRNA vaccination process, and it's gained a lot of press lately because of the whole Pfizer and BioNTech vaccine that is currently in phase 3 clinical trials and the promising data that it showed. And in this video we will look at the mRNA vaccination history, as well as sort of go through the process, the safety, advantages, disadvantages, and why it's considered disruptive technology and how it can even affect things down the road such as cancer as well as allergies, on top of treating other infectious diseases. And so stay tuned and let's just jump straight into it. So hello, I am Dr. Jack. I am a board certified anesthesiologist and pain management physician. And on this channel, the focus is on helping you live a healthier, happier, and wiser life through knowledge. And please feel free to check out my past videos. And if you like what you see here, please don't forget to hit the like button to help the YouTube algorithm, as well as subscribe and hit the notification bell so that you know when my videos would drop next. And typically they come on the weekend. And if you have comments, please feel free to put them down below. I'm very good about answering them. So without further ado, let's just jump straight into this topic at hand. Let's start off by talking about a typical virus and how exactly it works. And what you have is a virus, and the whole point of a virus is essentially to get into your body's own cells and to replicate. And it does it through many various mechanisms. Today we'll mainly be focusing on the COVID-19 or SARS-CoV-2 or novel coronavirus, whatever you want to call it. But anyway, moving forward, so the virus wants to get into the cell, and once it attaches on the surface, what it does is gets absorbed into the cell and sends its RNA material into the cell to essentially start hijacking the cell's machinery and to start replicating the material. Now, the coronavirus attaches through these little proteins called spike proteins on the outside of it to the surface of the cell, and it attaches through a cell receptor called the ACE2 receptor. And the reason a lot of people get very sick, mainly developing respiratory symptoms and everything else, is because there's quite a lot of the ACE2 receptor lining the respiratory tract. They're also found in the GI tract and various other places, but it is more predominant in that area, and hence why we're seeing more symptoms in that regard. But moving forward, the majority of viruses, the vaccination, and this has been done for over 70 years now, essentially what they do is they take the virus and they inject it into an egg. And typically it's a chicken egg or some other mammal egg. And basically it's introduced in there and allowed to replicate, and then the egg is sacrificed, and then they have to purify it and process it and do all types of things to it to essentially ultimately end up with the vaccine that you get at your doctor's office or any clinic or pharmacy and things like that. And so, as you can imagine, it's a rather cumbersome and lengthy process to inject in an egg, let it incubate, and all the processing. It's very expensive as well as just very time consuming. And if you're going from point A to point B, if you have so many steps in between, at every step there's the possibility of creating an error or a contaminant. So as mentioned, the messenger RNA vaccination route has actually been around for quite some time. And so it has been used to essentially vaccinate things like the H1N1 influenza, as well as Ebola. And again, it dates back to like 1990, and they've sort of been tweaking delivery mechanism, as well as obviously looking at the safety and just the overall efficacy or effectiveness of how to deliver a vaccine in this route. And it's also been used to look at how it can possibly use your body to essentially fight off cancer and allergies as well. If you're like me and I'm basically allergic to almost everything except dogs, it seems. This is very awesome news, and something I hope that the scientists and researchers continue to work on, because boy, I would love to stop taking Zyrtec and Flonase. So let's talk real quick about what messenger RNA is. So historically, all living things are made up of DNA or RNA, right? So if you're a human being, you have the messenger or the double-stranded DNA, right, which we all learned in school. And messenger RNA is when the DNA is essentially transcribed. And so you get a little piece of it that gets transcribed. And ultimately, the messenger RNA comes out of the nucleus and into the cytoplasm, which is within the cell, but not within the nucleus of the cell. And within the cytoplasm, the little messenger RNA carries essentially the blueprint for making something called protein. And proteins are essentially the building blocks of everything within your body. You know, everything from like your hair to your muscles to hormones to enzymes to antibodies essentially are made from proteins. So naturally, if you are going to create a mRNA vaccine, what you need to know is the entire genomic sequence of what you are trying to create a vaccine to. What they have done is been able to isolate a part of the RNA that codes for the spike protein. And the spike protein, again, are the little receptors on the outside of the virus that it uses to attach to a cell, get inside, and again, hijack all that machinery to start pumping out more of the virus. They then inject it into the body. So one of the things is that anything that presents in the form of a messenger RNA just floating within your blood actually gets destroyed pretty quickly. And what they've done here at Pfizer and BioNTech is basically they have encapsulated it with a nanoparticle lipid bilayer. And it makes me think of essentially, you know, you probably eat pigs in a blanket. So think of the pig or the little hot dog as the mRNA that's inside and the blanket or the doughy part on the outside essentially protecting it. And so they've created in that sense as a transport mechanism to get the mRNA to the targeted cell. And so once it is actually inside the cell, what ends up happening is you have these things called ribosomes within the cytoplasm, and it attaches to the mRNA and it starts transcribing the protein that we talked about earlier. So then your body creates all this antibody to the spike protein. You have all these other cells that kind of come into play, things like macrophages, dendritic cells, B cells, T cells. We won't go into the details of all that. Just know that essentially everything I'm telling you here is a lot more complicated than what I'm explaining, but I'm trying to just kind of simplify it down to get the point across. The memory B cells and T cells essentially will remember that it has seen this protein before, so that when the coronavirus actually comes into your body, what ends up happening is that your body will create all these antibodies, and they start recognizing the little spike protein that's on the surface of the virus. And the little antibodies, they don't actually look like balls, they look like little Y complexes, if you will, but just kind of getting the point across here. The antibodies just essentially start attaching and attacking the outside of the cell constantly here. And what it does is basically it does not allow the virus to bind and get into the cell. And therefore it buys the body time to destroy the virus and get rid of it. So let's talk about a bit more about the Pfizer and BioNTech vaccine and why it's a big deal. Know that currently there are over 200 different companies undergoing research for coming out with a COVID-19 vaccine, and over 40 of them are currently within clinical trials. The Pfizer BioNTech vaccine seems to be furthest ahead at this time because they are in phase 3 trials, and we'll kind of get into that a little bit more here in a bit. And you know, essentially what the pandemic has done has accelerate all this, you know, like many things. If you throw enough money and resources at it, obviously everything starts to get done at an accelerated pace. Let's just kind of go through some details of their vaccine. Here, this is from the actual Pfizer website. And as you can see, they found it to be more than 90% effective, and they had over 43,538 participants. You know, it was people with a diverse background. They ultimately found 94 confirmed cases of the trial participants that ended up with positive COVID-19 infections. And they started looking at these 94 individuals to see whether or not the vaccine was effective. And at this point, they unblinded the study. It's important to know that this was a double-blinded randomized trial, which is very important. What that means is that they took participants for it and Some people, half the people got placebo, the other half actually received the vaccination. And even the researchers, the ones that were actually giving the injections, did not know which was what. And this removes a lot of the bias that is involved. So once they found these 94 individuals who ultimately did get infected, they started looking at how efficacious or effective the vaccine was, and that is essentially how they ended up at 90%. So one of the things was that they found, similar to previous studies, a lot of it is in the New England Journal of Medicine, where they have conducted quite a bit of phase 1 clinical trials. And actually, we should probably go through that just real quick. And if you take a look at the next slide, it's important to know what phase 1 to phase 4 clinical trials are. And in phase 1, you can see that there are not that many participants, 20 to 100 participants. And this is where they're mainly looking at the safety of the clinical trial. Actually, prior to phase 1, they're looking at it within mice because of the genetic similarity to human beings. And then as it advances to phase 2, they start enrolling more people, and then to phase 3, you have several hundred to several thousand people. And then phase 4 typically is conducted many years down the road, and they're kind of looking at the long-term effects there. With the previous New England Journal of Medicine studies, as well as with the research that was done under the Pfizer BioNTech vaccine, they found similar side effects. The most common were things like injection site soreness, headaches, some mild fever, muscle aches, as well as fatigue. And for any of you that have gotten vaccinations for anything, these are pretty common type side effects. So one of the things I want to talk about is the emergency use authorization and what that means. So, a lot of people think, oh, that just means they're trying to rush it out and they're not looking at safety and efficacy. And I mean, that's actually the two most important things that they're looking at in a scenario like that, is the safety and how effective it is. And what the emergency use authorization means when you're trying to essentially get a vaccine to society as quickly as possible is that it cuts through a lot of the red tape in regards to paperwork and all the processes in place to ultimately get it out. So let's talk about some of the challenges that I foresee. One of them obviously is scaling of the vaccine, and you're talking about vaccinating the whole world essentially, and that's not easy to be done. And the fact that it is mRNA actually helps because, again, it can be quickly made as opposed to incubating it in an egg. And the other problem with it is that it has to be stored very cold and minus 70 degrees centigrade. And so various places that will be dispensing this, as well as the transportation method, there will be quite a bit of resources that would have to be put in place for that in order to ultimately have it be effective once it actually reaches the patient or individual. This is where I think it's great that companies like Tesla is creating what they call an mRNA printing machine. And they're working with another company called CureVac. I think it's great to just see so many different companies kind of pile in to try and solve this problem. For those of you that know me, you know that I'm a huge Tesla and SpaceX fan, hence the t-shirt. And just a little bit of investment advice from a doctor. Buy some Tesla stock and you can thank me in a few years, but invest at your own risk. But anyway, it's another company that is very big in disruptive technology. And again, for those of you that know me, I am a huge fan of disruptive technology. So one of the other big questions is, so it's great that you got vaccinated, but I mean, how long are you actually protected for? And obviously one of the big question is, well, long term, what happens? And they're talking about maybe in April they will start rolling this out. And I imagine that, people that are at higher risk, like first responders, like doctors and nurses and elderly, might be the first ones to get it. And given sort of the urgency of the pandemic and how it's shutting down entire economies and affecting so many people on so many different levels, given that environment, there's no way we're going to be able to wait for years on end to basically see what the data is that far out. And I know a lot of people may have issues with that. For me personally, one of the reasons I did all this research was to try to figure out, okay, well, I'm a doctor. I'm probably gonna be one of the first ones to get it. What is all this about? How safe is it? And after doing the research and taking a deeper dive at how much is in the literature in regards to mRNA vaccines and how it works within the body, understanding how things work at a cellular level, I can say that I am comfortable getting this vaccination once they actually roll it out. I also feel like it's my duty to get it done as a physician as well. But that is why a 90% efficacy rate is such a big deal. For some of you may not know that actually for a vaccine to be approved, it only needs to be 50% effective. And so for 90%, that's great, because the higher that percentage, the more likely you will get herd immunity, where basically a group of people would be immunized enough to where the virus doesn't really transmit very well between people. And so the higher effectiveness of the vaccine, the fewer the amount of people that you need to actually vaccinate in order to get that herd immunity. So that pretty much sums up this video. I hope you found it valuable. Again, if you like what you saw, please like, subscribe, and hit that notification bell so you know when my next videos will pop up. And I hope that also that you realize that these sorts of disruptive technology, what is disruptive technology, right? It actually is something that will disrupt a space or an industry or a business where it essentially changes the whole landscape. And that's how I view the whole mRNA vaccine. And it is something new, and people will have a hard time sort of grasping it initially, as well as the speed at which it can be done. It's just something new that we're not used to. And I would encourage you to read this great book by George Friedman that I read 10 years ago now. It's called The Next 100 Years. I think as a society, we need to get used to seeing disruptive technology, much like how, like Tesla or SpaceX, and, how Tesla is disrupting the entire energy and, electric vehicle space, and as well as manufacturing. And I could go on and on. I'm a huge Tesla fan, so maybe I'll do a YouTube video on it. Doctor talks about Tesla. Anyway, I'm sure that will get a lot of views. The Next 100 Years is written by George Friedman, and in that book, one of the things that I really remember that stood out for me was him saying that, if you're alive right now, you're reading this book, you are living during a whole new Renaissance period within our species, and something equivalent to like the industrial age. And this is more of the information age, and it kind of starts with the internet and technology, and how computing has just moved at such a fast pace. And every year your computer is twice as smart, right? And so initially there was computers, and man was smarter than computers, and then computers one day beat man at chess. Everyone's ears kind of perked up. And then, today you have artificial intelligence, and you have basically computers doing a lot of the research overnight, and they don't need a break. They can work 24 hours. They're just so much more efficient at accomplishing everything. And so you will see new disruptive technology essentially come to market much, much faster over time as essentially artificial intelligence and all these other things become better. So I hope that kind of clears up some of the questions surrounding this whole situation. And so till next time, take care, stay safe, bye-bye, Pura Vida.